That's right. Okay, this one's called Other Angles. It's 9.6. There's one tiny thing from 9.7. It's only one box, and this is called, we'll call it Other Angles for now. Okay. So here's the deal. So I've got two chords that are crossing each other inside a circle. Right, you guys are cool with that part? Well, they form two angles, right? They form this angle here, and they form that angle there. And those angles are, of course, they're vertical angles, right? Okay. Because any two lines, we know that. But that's not the part that we're working about here. We can, if I call this angle 1, then I have two arcs that I'm dealing with, right? I have this bigger arc over here, and then I have this smaller arc over here. Do you guys see that? Okay, let's see highlight. Okay, well, we can actually find the measure of angle 1 using those intercepted arcs. And here's the deal. So the measure of angle 1 is equal to, if I give these some names here, let's give these some names. Let's call that A, let's call that B, let's call this C, and let's call that D. I always just look at the far arc and the close arc. Right? The arc that's across from it is, we're going to call that, what? AB and CD, so we're going to say, is equal to the measure of AB plus the measure of CD divided by 2. Okay? So the measure, that angle 1 right there, instead of it actually being exactly equal to the arc itself, and instead of it being half of it, it's the average of the two. Okay? So if your point is not the central angle, nor is it an inscribed angle, it's somewhere in between, then the angle formed is equal to half the sum of the arcs. So the average of the two. So here is an example of what we mean by that. So angle 1, right? Angle 1 is not a central angle. It's not on the circle itself, right? It's somewhere in between. So we can find angle 1 by taking the average of the intercepted arcs. So the measure of angle 1 would have to be 112 plus 44, then divide by 2, the average of the two intercepted arcs. So the measure of angle 1 would be, what's 112 and add 44? Okay. So therefore the measure of angle 1 would have to be 78 degrees. So therefore this angle here, 78 degrees. Okay, so let's say we have two chords that cross inside a circle. Two chords that cross inside a circle. What I'm going to do is I have 4 segments of a chord. So I have the segment that's cut by each of them. So if I call this W, and that is from this point to that point, call that Y, call this X, and call this Z. So do you see the 4 segments that I have?
Yes.
Yep, so the two chords crossing inside of a circle creates these 4 segments, all right? The relationship between them is such that W times Y, so this segment times that segment,
X times Z.
yeah, exactly, equals X times Z.
WG.
There's no G anywhere. There's no G. That's a Y. Yeah. WY equals X times Z. Okay? So let's give you an example of this. I'll stay on the same box. I'll stay in the same picture. So check it out. I've got a circle. I've got 2 chords here. Okay? If this is 8, and this is X, and this is 6, and this is 16.
So this is box 4.
Yeah. It's an example. So my chords are, I have this blue chord here, and I have a yellow chord here. Okay, the chords cut up 4 sections. 8 and X are on the same chord, and then 6 and 16 are on the same chord. So the relationship between them is such that 8 times X equals 6 times 16. That's what it says. So therefore, we can actually determine X by saying 6 times 16 all divided by 8. divided by 8 should be 12. That's a strange relationship.
If you plugged in like 7.
Here's what we're going to do. Here's the 3 pictures that we're going to draw. We're going to draw in the first picture there with that first circle, we're going to draw a point outside the circle. And then we're actually going to do that for all 3. Point outside the circle, point outside of the circle for each of these. Okay? The first picture that I can draw, if I have a point that's outside my circle, I could draw 2 secant lines through my circle. So it looks something like this. Right through there and right through there. So that would be from that point going through the circle is 2 secant lines. You guys agree with that statement? Okay. Now I'm going to draw 1 tangent line, like that, and 1 secant line like that, like that. You guys see it?
Isn't that a
Secant rays, yeah, secant rays. Okay, there you go. Okay, there you go.
Why is one going through and one's...
Well, I'm just giving you 3 scenarios here, right? Okay. Or I could draw 2 tangents. Okay, so here's what's going on. So if I have a point outside my circle, which I do over here, this point, or this point, I can come up with 3 scenarios of how I could draw lines to the circle. Okay, I could either draw 2 secants, 2 tangents, or a secant and a tangent. Is that fair enough? I mean, if I kept going, these would be lines on either side. Okay, okay. In either case, or in all of the cases here, notice that there is an arc there and an arc there. There is an arc there, and there's an arc there, and then there's an arc there, and there's an arc there. You guys see the 2 arcs? Yeah, it's true. Yeah. And then do you see that down here, this is an angle formed. Call that angle X. Call that angle X. Call that angle X. You guys see that too? All right. Well, in all the situations, this is the far. That's the far chord, or the far arc, and this is the close arc. You guys agree with that?
Yeah.
That's the far one from the angle, right? And this is the close one. This is the far one, and this is the close one. Well, in all 3 cases, the measure of angle X, which is my angle down here, all these right here, is going to be the far one minus the close one divided by 2.
The farther out the lines go, the more of the triangles like inside.
It's just like magic number.
Okay, here's 2 examples to hone in this theorem. So what I like to do is I like to show, okay, this one's the far one. This is my far arc. This is my close arc. See that? And this is my angle that's been way outside here. So what's the relationship between these 3 pieces here? Okay. I know that 20 degrees has to equal the far one, x minus 40 degrees, all divided by 2. That's the relationship that I know.
Wait, so the one that's closed off, which is like 20, that's going to always be the first one. But then how can you tell far versus...
So from the point outside the circle, there's the angle.
Oh.
Go over here. This is the far one, and this is the close one. Does that make sense? The far and close one, Jake?
Got it, yeah.
Yeah. So
Is 20 or 40 close? 20.
no, 20 is the angle, or the angle over here. Right.
Oh, okay.
40 is the close arc. X is the far arc. Okay. So the relationship between all of these. So it must be the case that 40 is equal to x minus 40. So therefore, what does x have to be?
80.
X has to be 80.
70.
Okay. Now the other side. Check the other side. Again, this is the far arc, right? And this is the close arc, the yellow one. So what's the relationship between all of these things? Well, we know that 38 has to be the far one, which is 146, minus the close one, which is x, all divided by 2. You should get 70 degrees for that one there.